Experiment 2. Plotting and analyzing linear graph. At the end of this lesson, you should be able to develop skill in plotting and analyzing linear graphs. List of apparatus: graph paper, pencil, and long ruler. Theory of the lesson. Graphs are often used to represent the dependence or relationship of two or more experimental quantities. Commonly, the independent variable is represented by the x-axis and the dependent variables is represented by y-axis. There are many shapes of graphs. However, in this lesson, we will focus only on linear graphs. Linear graphs obey the following equation: y equals mx plus c, where m represents the gradient of the graph, c represents the intersection on the y-axis. Answering questions. So now we are going to implement the theory into practical. You are going to plot and analyze a graph based on the data given in table 1. The data is about the period of oscillation T of a simple pendulum for 6 different lengths L. In the table, you are given length L in centimeter and 3 values of period T1, T2, and T3 in second for each length. Instructions. First, copy and complete table 1. Second, after completing the table, you need to plot a graph of T square against L. Third, determine the gradient of the graph. Finally, by using the given formula T equals 2 pi square root L over G, determine G from the gradient of the graph. In order to answer the question, you have to copy and complete table 1. A. Calculate the average value for period T bar for each length. Example, for 10 cm, by using the equation given below, the average period T bar is given by 1.1 plus 1.1 plus 1.0 divided by 3. Therefore, the average period T bar equals 1.07 seconds. B. Repeat the process for 20 cm, 30 cm until 60 cm. C. Then you fill in the column T bar in second in table 1. In general, you are allowed to write only up to 3 decimal places maximum in the final answer. In this example, however, we write only in 2 decimal places. We need to be consistent in writing our calculated values. D. The next step is to calculate the square of average period, T bar square. Example, for 10 cm, T bar square equals 1.07 square. Therefore, T bar square equals 1.1449 seconds square. But you can only write up to 3 decimal places. Here, however, we use 2 decimal places only. Therefore, T bar square equals 1.14 seconds square. E. Repeat the process for all T bar square values. F. Then, fill in the column t bar square in second square in table 1. In general, you are allowed to write only up to 3 decimal places maximum in the final answer. In this example, however, we write only in 2 decimal places. We need to be consistent in writing our calculated values. Plotting graph of t square against L. A. Procedure in plotting graph. Number 1. Write the title of the graph at the top center of the graph paper. Refer to graph 1. Number 2. Draw the x-axis and y-axis. Refer to graph 2. Number 3. Identify the independent and dependent quantities and their respective unit in the experiment. In this case, the x-axis is representing length L in centimeter and the y-axis is representing the square of the average period t bar square in second square. Refer to graph 3. Choose the appropriate values according to the data for the x-axis and y-axis. In this question, the label for x-axis starts from 0 until 70 cm, whilst for y-axis, it is from 0 to 8 second square. Refer to graph 4. The decimal places for the label depends on the values of uncertainty of the graph paper. For x-axis, one smallest box represents 1 cm. The uncertainty of the smallest box is half of 1 cm, which is 0.5 cm. It has only one decimal place. Therefore, the decimal place for x-axis can only be written up to 1 decimal place. As a result, label for x-axis is written as 10.0 cm, 20.0 cm, until 70.0 cm. Refer to graph 5. For y-axis, one smallest box represents 0.1 second square. The uncertainty of the scale is half of 0.1 second square, which is 0.05 second square. Therefore, the decimal place for y-axis can only be written up to 2 decimal places. Subsequently, label for y-axis is written as 1.00 second square, 2.00 second square, until 9.00 second square. Refer to graph 5. B. Transferring data onto the graph paper. By referring to the data in table 1, transfer all values for x-axis and y-axis onto the graph paper. Mark X on the graph paper. Refer to graph 6. C. Calculating the centroid point. Calculation of centroid point is as shown. Centroid point is a point which are represented by the coordinate of average value of the x-axis and y-axis. It is represented by circled X to differentiate it from other plotted points. Refer to graph 7. D. Drawing the best straight line. After plotting all the data points and labeling the coordinate for the centroid point, Then you can draw the best fit line. Refer to graph 8. The criteria for the best lines are: it has to pass through the centroid point. It has to pass through as many data points as possible. It has to be representative, i.e., the numbers of data points above the line has to be equal or almost equals to the number of data points below the line, and the distance are about the same. E. Determination of the gradient of the graph. Number 1. Choose 2 points that could be read accurately along the best fit line. Number 2. Draw a right angle triangle using dashed line between these 2 points. Number 3. Make sure the size of the triangle on the x-axis is greater than 8 cm. Refer to graph 9. Number 4. Calculate the magnitude of the gradient. Number 5. The gradient of the graph is calculated as follows. The gradient of the graph is calculated by using this formula. M equal delta y over delta x equals y2 minus y1 over x2 minus x1. Transformation of the equation to linear equation. The relationship between the physical quantities may not be linear. However, this non-linear graph can be transformed into linear form, and hence a linear graph may be plotted. For example, in this question, the relationship between the period capital T of oscillation and a simple pendulum of length L is given by T equals 2 pi square root of L over G. By squaring both sides of equation 1, we get T square equals 4 pi square over G times L, equation 2. The general linear equation is given by y equals mx plus c, equation 3. From there, you notice that y represents T square, m represents 4 pi square over G, x represents L. And C represents intersection on y-axis whereby C equals 0. Determination of acceleration due to gravity G. From the gradient of the graph M equals 4 pi square over G, we rearrange the equation and we get G equals 4 pi square over M. After substituting the calculated value of the gradient M, we get G equals 401.20 cm per second squared. View the video presentation on graph plotting and analyzing linear graph carefully. Use them to guide you in completing exercise given in the lab manual. Refer to page 8 and page 9. We are going to discuss the questions in our next practical session. Thank you.
Jangan lupa like, share and subscribe video ini. Thank you for watching.